Hello, welcome back to the last lesson that we have in this topic of simplifying these radicals that involve multiplication, division, and some of the other properties of radicals that we've had. Similar sort of deal, we're just going to have some expressions that are a little more complicated than the last lesson. Now, before we get started, I'm just going to write something down. Unfortunately, I erased it from the last lesson. I'm not going to do all of it, but I'm going to write down the punchline. When you have the square root of x squared, the square root and the x squared do cancel, but really you should be wrapping an absolute value around the variable. So you're left with the variable x, but you have to wrap it around absolute value bars. I've discussed why that is in great length in the last lesson, so you should watch that if you don't know what I'm talking about here. And similarly, if you have x cubed and you're canceling it, so to speak, with a cube, then the cube root cancels the cube. Yeah, that's true. And you're left with the value of x. Now, you don't need an absolute value here, and it all has to do with, and I did a lot of examples, it all has to do with the fact that if x is negative, when you cube it, you get a negative number up under here, and you can take the cube root of a negative number. So what you end up with is the variable that you started with, right? Here, you can't take the square root of negative number, and when you square things, they become positive, so you end up through all the logic with that. So in some of these problems, we'll have absolute values, and the reason is if you're canceling a square with a square root with a variable, then it really is the absolute value of the variable. And again, if you haven't seen that or if that's news to you, then go back and take a look at the last lesson. All right, so our first problem is kind of interesting. 2 times a squared plus 4 times a plus 2. Now that whole thing is going to be wrapped up inside of a radical, square root. Now it looks terrible, right? The first thing you're asking yourself is, well, what do I do? Because there's plus signs in here. I don't know. You never taught us what to do when you have plus signs in there. That's true. But what is that thing under the radical? It's a polynomial. You have a square on the variable a, and then a first power on a, and then just a number. And so what you should try to do is don't make up new rules. Just try to factor what you have under here. Now, the first thing you look at when you try to factor something like this is you notice there's a 2 here, a 4 here, and a 2 here. So without doing anything else, I know that I can factor out a 2, and on the inside, I'll still have the a squared. I'll have a 2 times an a, and I'll have a 1. Make sure you understand that, because if you take that 2 and you multiply it in, you're going to recover what we have. Then you look at this and say, is that factorable? Well, if it is, it's going to look like the product of two binomials, right? A times a is going to give me a squared, and then 1 times 1 is going to give me 1. And I have plus signs everywhere, so I'm going to have a plus, and this whole thing is going to be wrapped in a radical. But this is a plus 1 times a plus 1. So really what you have is 2 times a plus 1 squared, and you're taking the square root of that. That's what you have. This is not easily seen from looking at this. Nobody is going to be able to say, oh yeah, it's this. No, you have to go through the factoring. Nobody can see that.